Hello and welcome to the first part of solving rational equations. We're going to be looking at three different things in part one here: graphing, cross multiplying, and a topic from previous lessons in math 1 through 3 called extraneous solutions. So the first part, what is the definition of an extraneous solution? When have they happened in the past? So generally, it's essentially when you find an answer to an equation that is going to make an error happen on your calculator. Those errors happen most of the time when you are trying to divide by zero, or if you're trying to take the square root of something that's negative. Both of those things give you answers that are extraneous, and they'll give you an error message on your calculator if you try to do them. So in rational functions, the most times we're going to have it are when we're going to end up with a zero in the denominator. So in that case, we are going to look at our first problem here. We have two equations that are set equal to each other, and we're going to be cross multiplying to solve. But if we want to figure out what x's are going to make us divide by zero, we got to figure that out first. So on the right-hand side, we can see that if x was -3, -3 plus 3 is 0. So one extraneous answer for this problem is -3. That could be possibly excluded from the domain. So the x can't equal -3. Otherwise, if we factor the left side, so that would be x minus 2, and then x minus 2 and x plus 2, and that's equal to 5 and x plus 3 on the right. So on the left-hand side, if x was 2 or -2, it would also have to be excluded because that would make the left fraction have a 0 on the bottom. So 2 and -2, all of those are excluded from the domain. X can't equal any one of those three numbers. If we solve this equation, we end up with one of those three, well, then we'll have to say that, well, that's an extraneous solution. So we're going to cross multiply now to solve this problem. We would have parentheses in all three of these parts. So I'm going to cross multiply by doing bottom left times top right and bottom right times top left. This should be old news for you guys. So we would end up with x minus 2 times x plus 3. And then we have 5 times x squared minus 4. And then we can just multiply everything out. So we on the left side would get x squared plus 1x minus 6. On the right side, we have 5x squared minus 20. So we're just going to move all three of these things to the right side. So this would be a 0 now. And so that would give us 4x squared minus 1x minus 14. So now we're going to try to solve this equation right here. So we're going to do quadratic formula real quick. So we have x is equal to -1 plus or minus the square root of -1 squared minus 4 times 4 times -14. And all of that is going to be over 2 times 4. And then we can just kind of simplify a little bit for our sources here. So we'd have a -1, which would just be 1. And underneath of the square root, we would end up with a 225. And that is over 8. So that right there, 225, I believe, is the square root of 225, I believe, is 15. And that, yeah, that's true. So we have 1 plus or minus 15 over 8. And the two answers we have at the end here are 1 plus 15 would be 16 divided by 8 is 2. And then our other answer for this equation would be 1 minus 15 over 8. And that would be -1.75. So these are our two answers down here. But we already said that 2 had to be excluded from our domain. So that means that 2 is the extraneous answer. And we would have just negative 1.75 as our solution. Now for the next part. So make sure you copy this down and pause the video here if you need to. Part 2. So like with any equation, you can use graphing as a method for solving. So if we look at each of these two separately, we want to see what x's would make them both 0. So equation 2, well, we can't have x be negative 2. That would make the bottom 0. So x cannot equal negative 2. And over here, x can't equal 5 for equation 3. And that would be our two domains, that x can't be negative 2 and x can't be 5 for our 2 points here. So since we have these two equations, this would be like if you were solving them equal to each other, like so. And so we have that equation, and you would solve it by graphing them separately. So on Desmos, that's really easy. But since I have my graphing calculator right next to me, we'll solve these using our graphing calculator as well. So I'll go into y equals, and I have 1 over x plus 2. And then I have 3x minus 3 divided by x minus 5. So I have my two equations, and then we're going to kind of do our standing viewing window. So I hit zoom, and then I'm going to scroll down to the 6th one for zoom standard. And you can see the center part here, that's where they're going to be intersecting. So I'm going to zoom in on just that portion of the graph. So I'll move my cursor over to there. And we'll hopefully be able to see exactly where they're going to cross. And you can see that they cross at two places. One's right there, and one's right there as well. So we'll just show real quick how to do that. So looking at the graph, second trace, go down to intersect. So first curve, kind of move over to where that first intersection point is. And then second curve, you kind of spend in that same area. And so it turns out that x equals negative 1 is our first answer. Our second answer, kind of move our cursor over to that part of the graph. And we can just kind of hit enter 3 times there. And our other answer is 0.33. So we have x equals 1 and 0.33 repeating. And if we move this, neither of those were excluded from our domain. X, we didn't get negative 2 or 5 as answers. So both of those would be the answers to this equation. And this is really important to take advantage of your graphing calculator and Desmos in this scenario so that you can save time for yourself, especially when you guys get to your final exam in a little over 5 weeks from now. And the last part of our intro is we have this equation 4. So we're going to see what we need to exclude. So the first thing I would do is kind of just factor that right denominator. So our first fraction wouldn't change at all. And then we've got 60 over x squared. 60 is going to be over. The factored version of this will be 8 minus 7 would be 1 and multiplied to negative 56. So we would have x plus 8 and x minus 7. Okay, so now if we are going to solve this, we need to figure out what we can include. So we don't want 7 because that will make this 0, and this is the same one over here. We also don't want negative 8. So x cannot equal 7 or negative 8. So if we look about how to solve this, so our first step can be to try to get rid of those denominators we have in common. So that's something we're going to be utilizing a lot in this section of the chapter. So if we multiplied both sides by x minus 7 over 1, x minus 7 over 1. Well, that would kind of divide out our x minus 7s on the bottom of both sides here. So you can see that those two will kind of cross each other out. So that means we have x minus 3 on the left side over 1, and then 60 over x plus 8. So now we're going to cross multiply. You have the two parentheses times each other, and then just 60 times 1. So we really just have 60 is equal to x minus 3 times x plus 8. And we can multiply that out to x squared minus 5, or no, plus 5x minus 24. And so 0 would equal x squared plus 5x. And we would just be subtracting 24 and 60 from each other in order to get that next answer. And so we can kind of approach that in a couple different ways. We can do quadratic formula. We could factor, we could graph it. And so what I would want to do is try to factor it here. So it turns out the factors of 84 is 12 times 7. So I would have x plus 12 and x minus 7. So that means that our answers for this problem here, if you guys still see that, is we have that x plus 12 and x minus 7 there. Well, that means that our answers are negative 12 and positive 7. Well, we already know that x can't be 7. So that 7 right there is an extraneous answer. So we don't want that. And that means that negative 12 is our only true answer that is not going to force us to divide by 0. And that is the end of our intro to rational equations. So we went over graphing to solve, using cross multiplication for just a fraction equaling a fraction. And we also talked about what extraneous solutions were, again, from our past. Thank you for watching.